suppose an economic agent lexicographically prefers X to Y. Again, now we are clear that when we say lexicographically preferred X over Y, I basically want a bundle which has more and more of X. I am not concerned with Y. I'm just concerned with X. Then her indifference curves are A, straight line parallel to x-axis. B, I want you to try this first because you should be clear with the concept of lexicographic preferences. Straight line parallel to y-axis. C, convexate. And D, L-shaped curve. First, give it a try, then I will tell you how to solve this. Please give it a try. Take a minute. So just think about this. See, in exam, sometimes you should also follow the method of elimination. If you don't know the answer, just give it 2 minutes and try with each option. The first option tells me that the lines are parallel to the x-axis, which means that the first option is telling me that this is my indifference curve. What is the property of indifference curve? What is an indifference curve? An indifference curve has the property that all points on indifference curve give you the same level of utility, isn't it? So this means that if I take a point like A and I take a point like B, if my indifference curve is parallel to the x-axis, then A and B should give me same utility. Should give same utility. But just think here. A has more of X than B. A has this much X. B has less X. If A has more X than B, then how can it give you the same utility? Clearly, utility from A is greater than utility from B. Based on this diagram that we drew, that if this is a point here and this is a point here, and this has more of good X, then this will be preferred. So which means that here I can clearly say that A has more utility than B, and hence they cannot be on the same indifference curve. So this gets eliminated. This is the wrong answer. Now I want you to try this. Please try this. Straight line parallel to the y-axis. Is this possible? Just try this. Is it possible that you have this as the indifference curve? Remember, X is lexicographically preferred to Y. So again, let's take 2 points. This is point A. This is point B. Point B clearly has more amount of good Y. Now let's think, okay? So we said that when X is lexicographically preferred over Y, it means that you will compare 2 bundles over X first. But if these 2 bundles have the same amount of X, then whichever bundle has more Y will be preferred. Right? What did we say? We said that, okay, if there is a bundle 10, 100 and there is another bundle 11, 0, then this bundle has more of X. Then you will prefer this bundle because you lexicographically prefer X over Y. But if there is a bundle 10, 100 and there is another bundle 10, 0, if 2 bundles have same amount of X, then you will prefer the bundle with more y. So here, although they have the same amount of x, B has more amount of y. So the utility from B is clearly greater than the utility from A. So from this, we know that these 2 points don't have same level of utility and cannot be on the same IC. The definition of indifference curve is violated. So which means that this is also a wrong option. Wrong option. This is not true. This is not true. Now, let's come to the last point first. L-shaped curve. So what I will do is I am going to go ahead and draw the indifference curve like this. Again, it's very simple. This is good x, O, y. Take any 2 points, point A and point B. B has more x than A. So utility from B should be greater than utility from A. So B and A cannot lie on same indifference curve. So this is automatically wrong. B has more of x, right, than A, and whichever bundle has more x should be preferred. So this answer is also wrong. Now, what am I left up with? I'm left up with the concept of convex set. Now, by elimination only, I know that this is the correct answer. But let's think about this. See, when I started teaching up the lexicographic preferences, I proved to you that no 2 points give you the same level of utility. So usually each point has different utility if they are lexicographic preferences. So what we can do is that we understand that actually lexicographic preferences are just given by points. Each point is a separate utility. Now, here is the thing that DSE will do and how they will confuse you. They could have very well written the fourth, this option as a point instead of convex set, and you would have known the answer, because we just proved that lexicographic preferences are simple points. But how do I show that this is a convex set? In order to understand that, we must know the definition of convex set. So what is a convex set? A convex set basically is the following. So any set such that you take 2 points in the set, you join it by a line, and that line lies within the set. If this is true, then it is called as a convex set. Okay. So what is a convex set? It is any set such that if you take any 2 points in this set, I am taking this point A and B, I join it with a line, and that line lies within the set, then it is called a convex set. Now, how do I prove that this point is a convex set? Simple. Imagine that I am going and magnifying this point. See, I've magnified it as much as I can. Now, within any point also, I can take any 2 small points, join it with a line, and that line will lie within that point. So I am magnifying the point, I am taking 2 dots, joining it with a line, and that line lies within the point. So because that is true, this point is automatically a convex set. Any point is a convex set. So the answer is that the answer is convex set. Remember, lexicographic preferences are given by points. No 2 points in this XY plane will give you the same level of utility. You will never be indifferent between any 2 points. And we have proved this currently that, A, G, E, all of this give you different level of utility. So B is preferred over A, C is preferred over A, E is preferred over A. So, we know that no 2 points give the same level of utility, and hence I cannot draw a curve through it. It has to be a point. So this is the final answer.